Okay, now let's start our class. And in this particular class, what we'll do is we'll convert all the formula programs that we have done with sub procedure through function procedure. Okay, so the first program is this, that is write a program to input length and breadth of a rectangle and display its area. So this was the first program that we did using sub procedure. So the same program we'll be converting using function procedure. And all the programs in this particular class is going to be with function procedure. Okay, so let me write this over here. Using function procedure. Okay. So as usual, what we have to do is we have to first of all declare. Then what we do is after declaration, we write CLS, that is to clear the output screen. Then we take all the required inputs. Then we call the function procedure and we write down the definition of function procedure. Now the difference between sub procedure and function procedure is sub procedure, it doesn't return any value. Function procedure, it returns a value. Sub procedure, it is called through call keyword, whereas function procedure is called through print keyword. So let's move ahead with our program and let's declare function. Now, since this is related with area, I'm simply writing area, and we need two inputs, that is length and breadth. So L and B are two parameters which we are using in our program to store length and breadth. So CLS. Now let's take input, that is input, enter length L. Now let's take another input for breadth, that is enter breadth B. Okay, let's make this also, let's make it same, that is okay, enter breadth. Now what we need to do is after we take input, what we do is we call the function procedure. So to call the function procedure, we call through print. Now we'll write down a small message, that is the area of a rectangle is. Now we call the function area, then we pass the arguments length and breadth, which are stored in LB. Okay, now let's end our main module with end keyword. Now here we are writing this message because this particular program will return only a, let's hold on. Okay, this program will return only a number, and that number is the value of area. So message doesn't get returned, hence we need to write message. Okay, that's why we have written this message, which you all can see in the highlighted form. Now let's go towards the definition of the function procedure, and definition starts with function. Then we write down area, then we give the parameters, that is length L comma B, length L, and for breadth B. So we are in the definition section now. Now here what we'll do is we'll apply the formula and we will return the value. So let's apply the formula. So I'm using A to store the value of area. Now let's multiply length with breadth. So this is our formula. Now our value is stored in A. Let's return it. And in order to return, first we write down the name of the function area, then we write down equals to, then we write down A. Now some of them, what they tend to do is they even tend to write down this parameters, that is length, breadth over here. Now if you do like this, then you program, it will show error. Now whenever we run our program, you can see that it is saying duplicate definition, and this is all, this error is showing because of this particular unwanted thing. Okay, that's parameter, we don't have to write over here, only the name of the function, and the name of the function is area, whereas this L comma B is the parameter, which is not required while we return the value, and the value is stored in A. So okay, let's run our program. So let's give 4 and 5 as length and breadth, and the area of a rectangle is 20. So, okay, I hope there is no confusion so far. Now let's move towards another program, and let's first of all do with rectangle only. Now what I'll do is I'll edit this program, and we will this time be calculating perimeter. Okay, instead of area, let's calculate perimeter. Perimeter, perimeter. Now for perimeter also length and breadth is required. So declare function area. So instead of area, what we let's write down the function name as perimeter, because this perimeter function name sounds good with our question. Okay, because we are about to display perimeter. So as usual, CLS is there. Now two inputs are required, length and breadth. It is also there. Now let's change in our message part that let's replace area with perimeter. The perimeter of a rectangle is, now let's call the function, which is perimeter right now, perimeter. Length breadth as usual, for length L and for breadth B. And this LB over here is, yes, argument. Argument is also known as real parameter or actual parameter, whereas this LB over here is a parameter, which is also known as formal parameter. Now let's go towards our definition section, and here is our definition part. So first of all, let's change this perimeter L comma B. Now what we need to do is we need to apply the formula. Now for perimeter, I'm using variable P. Now what we need to do is we need to apply the formula, that is 2, it is L plus B, L plus B. Okay. Now if we simply leave our formula like this, then it will show error over here because it is not yet correct. The correct form is we need to add this multiplication symbol as well. Now this is our complete Q basic expression. Okay. All the formulas that we apply has to be converted into Q basic expression. That is 2 is multiplying with the sum of L plus B. So multiplication symbol, we have to type it. Okay. Now our perimeter is in P. Now let's return the value of P. So for that, what we do is we first write down the function name, which is perimeter, and the value, which is in P. So let's check our answer. Okay, length 4, breadth 3. 4 plus 3 is 7 to the 14. So this is also correct. So after our programs with rectangle, let's move towards circle, and let's first find out the area of a circle. And that was also the first program that we did using sub procedure related with circle. So let's do it. Okay, here we are with our main module. Let's edit our question. Write a program to input radius. So RDIUS, radius, and display its area. So area, and this also we'll be doing using function procedure. So first of all, let's change our function name from perimeter to area. Then in this program we just have only one input, and for that input we will use one parameter, and let's give the name of the parameter as R. So R is the variable or the parameter which we'll be using in our program to store the value of radius. Now CLS is there, so let's input radius, RADIUS, radius. For radius R. Now this input is not required because there is only one input in our program. Now here let's change our message to area, the area of a circle. The area of a circle is, okay, area R. Okay, here we are with our main module. Okay, now one thing I would like to discuss over here is regarding the dollar sign. Now, as in the other video, what we have seen is if we are writing program through function, then we might have to write dollar sign. I'm saying we might have to write dollar sign. Okay, it's not that we have to write, but we might have to write. And the condition where dollar sign has to be written is we look at the return type of the program. Now, in this particular program, what this program will return is the area. Area of a circle will be returned, and area of a circle is a numeric value. Okay, whatever we print, that's what the function returns. So here we are printing the area of a circle, which is a numeric value. So this program will return a numeric value in the which is area of a circle. Therefore dollar sign is not required. Dollar sign is only required when the function or the program returns a string value. Whenever our function returns a string value, then we write down dollar sign. If it returns a numeric value, dollar sign is not required. So in this particular program and in our previous programs, a function used to return numeric value. That's why we didn't write dollar sign. Okay, so after being said all that, let's move towards our program and let's write down the definition with function area and R. Okay, here we are in our definition part where we'll apply a formula for area of a circle. And for that, I'm using variable A to store the area. Now, area is pi r square. Pi r square is the formula. So pi, now we can't write pi like this. What we have to do is we have to write its numeric form. So its value, the value of pi is 22 divided by 7. And this has to be multiplied with r square. So multiplication symbol is there, r square. So for square, we will be using exponentiation sign. So r square exponentiation 2. Here you can see this highlighted symbol is exponentiation symbol, which is used to calculate power in QBasic. Okay, these things we have already seen in class 9. Class 9, class 8, we have already seen. So this is our formula. Now you can just leave it like this, or if you want to modify this, then the better way of writing this is like this. I prefer to write like this. Okay, pi, then multiply with r square. Now if you use parenthesis, then what will happen is this will get evaluated, this will get evaluated, and whatever are the values, those two values will be multiplied with each other. So this is what I prefer, and most probably I'll be using this method, okay, using parentheses. And while creating QBasic expression, you can use as many small brackets as you want, but you can't use curly bracket and big brackets, okay? Those things you can't use. If you want to add more, again, if you want to add more brackets, then you can write like this, okay? You can add this kind of brackets, but no matter how many brackets you use, it's only small brackets. That's what you have to remember. So this is not required, so I'm just simply deleting this one. Okay, now what we are left to do is to return the value. And in order to return the value, what we'll do is we'll first write down the name of the function, which is area equals to, and the value which is stored in A. So let's run our program. So radius, now let's give radius as 14, and here is our answer. The area of a circle is 660. So now let's move towards another program, and this is also going to be related with circle, and it is, okay, now there is one extra function. Let's delete it, perimeter, which we have already calculated. So let's delete it. Okay, now in our main module, let's edit our program, display. Now this time we are going to find out the circumference. So circumference using function procedure. So let's first of all change our function name, which is circumference. Okay. Now we just have only one input. So for that input, we are using variable r. That is a perimeter. That is for the radius. Now let's take input. Okay, this line is already there. Now what we need to do is we need to change our message a little bit. Let's replace area with circumference, because this is what we are about to print, and call the function, which is again circumference. Okay, now pass the argument, which is r. It's already there. Now let's move towards our definition part. So here is our definition part. Function circumference r. Okay, now it's time to apply the formula. For circumference, I'll be using variable c, and let's apply the formula, and the formula is 2 pi r. So 2 multiplies with pi, which is already there, and the whole thing, then the whole product, and this whole product will multiply with r. So here is our r. So this is the formula to calculate circumference. 2 let's see from here, 2 pi r. And this is a perfect QBasic expression where we have used this multiplication symbol as well. Now let's return the value circumference, okay, equals to C. So basically this is our program with function procedure to calculate circumference. Let's check our answer. Radius, let's give 14 one more time. Okay, we have 88 as our answer. So this is the circumference of a circle. Now after this, let's move towards area of four walls program. Okay, so let's go to our main module. So here what we have to do is we have to take three inputs, that is write a program to input length, then we have breadth and height of a wall, and display the area of its four walls. Okay, now this is a program and we will be doing this using function procedure. So now this program is also related with area, so let's change our circumference to area. Now in this particular program also, if you think of this dollar sign, then your result or your conclusion should be we don't need this dollar sign. Okay, that is the conclusion it should be, because in this particular program what we are doing is we are printing area, and area again is a numeric value. In our previous program with circumference, it was also a numeric value, that's why we didn't use dollar sign. Here also we are calculating area, that's what we'll display, and function will return area, which is a numeric value. So dollar sign is not required, but what is required are the parameters, and we need three parameters now, and those parameters are for length, breadth, and height. So let's type in the parameters L, B, H. Okay, left for length, breadth, and height. So CLS is already there. Now let's take input. Let's start with length. And for length, I'm using variable L. Let's copy this. Okay, breadth and height. So let's edit this now. Let breadth. Now let's store this breadth in B. Now comes height. Okay, variable H and height. That is HEIGHT. Okay, so here is our input part. So after taking input, what we do is we call the function procedure. And in order to call, what we do is we use print keyword. Here we already have print keyword. Then we write down a message, because in this particular program only the value of area will be returned. So we need to write the message, and the message, it has to be the area of four walls is. The area of four walls is. Now let's call the function procedure, that is area. Now let's type in the arguments, which is L, B, H. So let's go to the definition part, and here is our definition part. Function area. Function area, we have three parameters, length, breadth, and height. Now it's time to apply the formula, and the formula is quite simple. So I'm using variable A to store area, and the formula is 2h L plus B. 2h L plus B, L plus B. Now, okay, 2 is missing, 2h L plus B. Okay. Now this this kind of thing is written in mathematics. In mathematics, we write formula in this way, but here what we have to do is we have to convert those mathematical expressions into QBasic expressions, and while converting into QBasic expressions, there are few things missing, and the missing is the multiplication symbol. Here 2 is multiplying with h, and the product of 2 and h multiplies with the product of sum L plus B. So 2h L plus B. So this is the actual formula. Now let's return the value area is equals to A. So this is how we write programs through function. Okay, now this particular section is returning a value. I hope you all are very much comfortable by now with returning a value and writing down the programs through function procedure. So let's check our answer. So length, let's give 3, breadth 4 and 5, and this is our answer as 70. Okay. Now after area of 4 walls, let's move towards the total surface area of a box program. Okay. Let's go towards our main module. And whatever programs we are doing, these kind of programs are frequently asked. Okay, one question is compulsory with formula programs. According to the curriculum, one question in SE has to be related with formula. Okay, so among whatever question comes, this is the same format that we do. Okay, for with sub procedure we have already studied. Now with function procedure we are studying. So let's continue. And let's write program for total surface area. And for total surface area, we need length, breadth, and height. And this time it is of a box. And display the total surface area. Total surface area of a box. And we'll be doing this using function procedure. So without wasting any more time, let's start. Declare function total surface area. So total surface area, let's write TSA for total surface area, and make sure that you don't write this full stop. Okay, it is not required, don't write it. Now parameters LBH for length, breadth, height, it is already there. So let's move towards the input section, which is also already there. Now what we need to do is we need to call. So let's change our message a little bit. The total surface area of a box. So this is our message, and let's call our function procedure, which is TSA, and the arguments LBH. Okay, now let's move towards our definition part. Here is our definition. Function TSA LBH parameters. So let's apply the formula, and the formula to calculate total surface area is I'm using T. Okay, T to store the value of total surface area. Okay, the formula is 2LB plus LH plus BH. Okay, this is the formula. Now, this formula is in a mathematical expression. Let's convert this into QBasic expression. So 2 multiplied with H, and length is multiplying with breadth. So L into B, L into H, and similarly B into H. So this is our perfect QBasic expression. So the only thing left is to return the a value, so which is TSA equals to A. So this is all we need to do. Let's check our answer. So for length, breadth, and height, I'm giving 5, 6, and 7. So let's see. The total surface area of box is 0. So our answer is not correct. So there is some problem in our program. Let's go and debug our program. So debugging is finding out the errors in our program. So let's check what our program has. Okay. In this particular highlighted statement, what we have done is we have applied the formula. We have applied the formula. We have applied the formula and stored the value in T. But while returning, what I did was I returned A. That's why the whole thing was mistake. So what I have to do is I have to return the actual value where the actual variable where the value has been stored, and it is not A but it is T. So let's run our program. 5, 6, 7. So here is our total surface area, which is 214 for this particular case. So okay, after total surface area program, let's move towards distance formula. Okay, let's move towards distance formula. So let's go to our main module. So for distance formula, what we need is we need initial velocity. Initial velocity. Then we need acceleration. Okay, after acceleration, what we need is we need time taken. So time taken. So these are the things that we require. And after taking all these things input, we are ready to display the distance traveled and display the distance traveled. And it is also with function procedure. So let's start our program and let's first declare. So declare function. So since this program is related with distance, I'm giving the function name as distance. Now here we need three things, and initial velocity, it is represented by u, acceleration by a, and time by t. So I'm using the same notations, okay, over here. Now let's take input for initial velocity, acceleration, and time. Initial velocity. Now let's store this in u. Now for acceleration, let's store this in a, and time taken. Time taken. Let's store this in t. Okay, our input is all ready. Now what we need to do is we need to call the function procedure. So let's edit our message over here. That is, this time it is the distance traveled. The distance traveled is, okay, here we have to write down the name of the function, which is distance. Now let's give the arguments, that is u, a, and t. So now we are ready for the definition part. So let's move towards our definition section. Press F2, you get this small dialog box. From there, select your procedure, function procedure, and press enter. So here we are with our definition, and here it is distance and u comma a comma t. Okay, so for distance, I'm using variable d to store the value of distance. Now let's apply the formula, and the formula is ut. So u is multiplying with t plus half. So for half, you can write 1 by 2, or you can even write 0.5, okay, because 1 by 2 is equal to 0.5. But what I have found is most of the students, they find this particular thing easier, okay, half. So I'm using the same thing, 1 by 2, half at square, multiply with a and multiply with t square. So t exponentiation 2, and this exponentiation is for power. So this is our formula. Now the only thing left is to return the value. So distance, name of the function, and the value, which is stored in d. Okay, now let's run our program. Initial velocity, okay, 7, 8, and 9, and this is our distance traveled. So this is the formula, sorry, this is the program to calculate distance travel. Okay, so let's continue with another set of formula program, that is with temperature. Now with sub procedure also we have written one program that is with centigrade to Fahrenheit. So that's the program we will be doing with function procedure. Okay, this time with function procedure. So let's first write down the question, that is, write a program to input temperature. Okay, to input temperature in centigrade and display the equivalent temperature in Fahrenheit. Okay, this is the program that we'll be doing. Now this is also a kind of formula program, because there's one formula to convert from one temperature to another. So at the beginning, let's declare our program. Declare function. Declare function. Okay, now this is temperature program, so I'm simply writing it temperature as the name of our function procedure. Now we'll be taking one input in centigrade. So let's use CLS. Now let's take input, that is input, enter temperature in centigrade. Now we'll store in C. Now it's time to call the function procedure. So we'll be using print keyword. Now what we'll do is we'll give one small message, the Fahrenheit temperature is, so we'll call the function now temperature. So let's write C, and here is the end of our main module. So we have declared, we have taken input, we have already called. So this ends our main module. Now let's move towards the definition, which starts with function. Function temperature. Temperature C. Now we are in the definition section. Now here we'll apply one small formula, and the formula to convert centigrade to Fahrenheit is this. And to store the value of Fahrenheit, I'm using variable f. So f is equals to 9 multiplied with c by 5, or it is 9 multiplied with c divided by 5. So 9c, that is 9 multiplied with c. This is the value of centigrade, and the whole thing has to be divided by 5. So you can even keep bracket over here, no problem. And we have to add this with 32. So basically this is our formula. Now once the formula is evaluated, our value of Fahrenheit will be stored in F, and this is the value that we have to return. So temperature, the name of our function, has to be written, equals to, then we write down the value which is in F. So whatever value is stored in F, that will be returned to the main module, which is here, and that value will replace this particular part from where the function was called. So temperature C will be replaced by the value that has been returned by the function, and everything will be displayed with the help of print keyword. So let's check our answer. Centigrade, let's say 100 centigrade is equivalent to 212 Fahrenheit. So okay, that's the end of our temperature program. Now let's move towards a program which is related with quadratic equation. Okay, now you have already studied this in mathematics, that in whenever there is a mathematical algebraic expression in quadratic form, then there will be two answers, and those answers are called roots. So that's what we are about to find out. So for that root, what we need is, we need three things. We need the value of a, b, and c. So what we'll do is, we'll take a, b, and c as an input, and we'll calculate the roots of the quadratic equation. So write a program to input. I'm simply writing it. Write the program to input a, comma, b, comma, a, b, and c. Okay. I don't know what these a, b, and c refers to. Maybe you all people know, because you have already studied this. I studied this, but I've already forgot this one. What I only know is the formula, and what I know is the value of x, which we are about to determine, is called roots. So write a program to input a, b, and c, and display. So display the roots of the quadratic equation. Okay, the only thing in this program is how we write down the formula. Okay, the formula looks a little bit complicated, okay, compared to other programs. That's why I'm actually doing this program right now. So let's see how this is done. Okay, so declaration part, declare function. Now since this we are calculating roots, so I'm simply writing roots, or simply write root, no problem. Now we have three inputs, and the three inputs are for a, b, and c. We'll take the values for a, b, and c. Now enter. Now let's input, that is enter the value for a. Okay, that's how we take input. Okay, let's copy, paste, and let's paste one more time. Now, and value for a, now it is for b, and it is for c, and for c. Now let's delete this too. Okay, now what we need to do is, we need to call the function procedure. And in order to call the function procedure, what we'll do is, we'll use one message as well, because in this particular roots, what we'll do is, now in this particular program there will be only dealing with only one value. Okay, now actually there are two values, but our program will only return one value. So what we will do is, or what you can do is, you can call function two times and calculate the value, but here we are not going to do anything as such. What we'll do is, will simply stick to only one value, and we'll use the formula for the positive one, that is minus b plus root over b square minus 4ac upon 2a. You'll see while we will write the formula. So the root is, now let's call the function, that is root a b c, a comma b comma c. So let's go towards the definition part. So here is our definition part. So let's write function root. Now what I want you to pay attention is in the definition, converting those mathematical expression into arithmetic expression. Hopefully you can see this screen right now. Now formula is like this: x is equals to minus b plus minus, now we'll just stick to plus, and under root b square minus 4ac. This is the formula, b square minus 4ac divided by 2a. Now this is how it is written in mathematics. Now this thing we have to convert in QBasic expression, and while we convert this into QBasic expression, it will look something like this: x is equals to minus b as it is, then we write on plus as it is. Now okay, just hold on. Okay, equals to, we have to write everything in a single line. Okay, minus b plus, now look here, under root. Now for under root, if anybody is confused, then under root is like this. Okay, I'll just show you. Now suppose if there is x to the, okay, under root 4. Okay, now if we have to remove this root sign, then how we can write this particular expression is in this way: x to the power 4, then 1 by 2. What this under root, when we remove, what happens is power will be multiplied with 1 divided by 2. This is how we write. Okay, now let me give you one more example. Now suppose there is root, okay, let me partition this, okay, x square, or you can simply write x only. Okay, now if you remove this root, what will happen is, x is as it is. Now if you remove this root, then in the power of x, what will happen is, when we remove root, we have to write 1 by 2. This is how we remove root. As soon as we remove root, we get 1 by 2 as a power in x. Now suppose if it is a cube root, suppose if it is like this one, you can see here, if we remove root, then at this time it is going to be 1 by 3. Suppose if it is like this, under root 5. Okay, then if we remove this under root 5, then x will be with power 1 by 5. So this is how we write in mathematics. So same thing we have to do over here. So what we have to do is, we have to remove this root over here, because there is no root sign. Okay, we don't have this kind of root symbol in QBasic. So what we have to do is, we have to remove this root. So this root is for this whole b square minus 4ac expression. So what we have to do is, let's first write b square minus 4ac, then we'll enclose b square minus 4ac expression with the root. Okay, so what I'm trying to say is, b square is b exponentiation 2. So let's write this in bracket. Okay, let me write this bracket properly. B square minus 4ac. 4 multiply with a, and c multiply with c. Now the whole thing has to be under root. Now this under root, we are removing under root. So for under root, what we have to do is 1 divide by 2. Okay, now this is how we write in mathematics. But if we have to convert this in QBasic expression, what we have to do is, this whole thing has to be written with exponentiation sign. This whole thing under root 1 divided by 2. So this is how we convert. So one more time, pay attention. b square. B square is b exponentiation 2, and these brackets over here, these brackets over here are for b square minus 4ac. Now there's nothing new over here, and this whole expression, for this whole expression we are using these brackets, this and this brackets. Okay, exponentiation, and when we remove this there will be a power 1 by 2, and for that power we are writing exponentiation 1 divided by 2. So this is how we have to convert our formula in QBasic expression. So this is what we will be writing. So let's go back to our program. So here is our QBasic editor. Okay, so let's first, okay, I guess we have already written the question. Okay, now only thing is to, okay, now write down the formula. So I'm writing variable x. Now what we need to do is minus b. So write minus b, then plus, okay, plus as it is. Let me delete everything now. Okay, b square minus 4ac. So for b square, b exponentiation 2, this is b square minus 4ac. So 4 multiplied with a multiplied with c, and the whole thing. Now for whole thing, let's use another bracket, and this whole thing has to be powered by 1 by 2. Powered by 1 by 2, 1 divided by 2. So this is our QBasic expression. Now once this statement is executed, we get one root, and that root will be stored in variable x, and this value we have to return. So first write down the function name, which is root root, then write down the value, which is x. So this is basically how we can calculate the root of quadratic equation. So okay, here there's a slight problem that this whole thing has to be divided by 2, and we haven't yet divided by 2. So the whole thing means this whole thing from here till here, this has to be divided by 2, then only we get the correct answer, 2a, and 2 multiply with a. So sorry, 2 multiplied with a. Actually this was what I was forgetting. Okay, this was what we forgot. This whole thing, that is minus b plus b square minus 4ac under root divided by 2a. Now let's check our answer, and our answer 1, 10 minus 24. So the answer is 2. One of the answer is 2. Now there is another answer, and for that what we have to do is, if we write minus sign, then we get the other root. But we are not concerned with that. We are just concerned with one of the roots with positive sign, and here is the formula. So we have evaluated. So that's it with the formula programs. I hope you have understood. Now what you need to do is you need to write down all these formula programs in your copy and send me the snapshot of it in the Google Classroom. Okay, see you everybody. You all have a great day. Thank you so much. Thank you.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.